It's time to end the mystery. So we've dealt with radian angle measure because you've been switching it over into degrees on your calculator. Now we're going to finally see what a radian is, why you would ever want to deal with it, and how to convert between degrees and radians. Here it goes. I want you to first have a sense of where degrees came from. Degrees are arbitrary, meaning we just kind of made them up. And it's because in a year, there's 365 days. 365 doesn't divide nicely. So as societies for thousands of years, we just picked a number that was close and nice, 360. That's why there's 360 degrees in a circle. It's because there's 365 days in a year. That works for a lot of things. Degrees have their place. But there is another way that makes some more complicated stuff easier. So in calculus, in engineering, in physics, measuring your angles in radian does sometimes make the work a lot simpler. Let's take a look at what a radian is. Now, I'm going to try and explain a little bit, and then we're going to look at an animated GIF together that I think does a good job showing how a radian works. Here's what we're saying. Imagine an angle. So I'm just going to draw an angle. So there's my initial side. And then let's go, how far do you want to go? Let's go in a positive direction to about here, something like that. Put in my terminal side. All right, so there's my angle. Here's what a radian angle measure is. Now you'll notice there was a circle drawn. So from here to here, this is the radius of the circle. What we're going to do is define the angle based on how much of the circumference of the circle is between my initial side and my terminal side. And more specifically, we're going to count how many radius lengths, so this length right here, there are along this angle that we've made. So as I go along the curve, I'm going to have to estimate, once I get to about here, this curved length is about the same as what the radius is. If I keep going and keep going, this curved length that's left, that's about what the radius is again. So this arc length that is related to this angle is about twice the radius of this circle. Therefore, this angle is about 2 radian. That's what we're saying. So radian is just looking at the length of an arc in a circle that matches up with your angle, and then describing that length in terms of how many radii of the circle it takes up. So that's the gist. Now I'm going to insert here this image, which is actually a pretty good image. And it will show the same thing in an animated form. So there you go. This angle is 1 radian because the arc you intercept is 1 radius of the circle. Now, once you get going, you'll see that, okay, now we see a pi coming in. We're going to talk about what that means. And then if you spin all the way around the circle, you get to a 2 pi, and we'll make sure we talk about what that means as well. So there you go. That's the gist of radian measure. Now to convert, which you are going to be expected to do from here until the rest of forever, we need to have a little bit of sense of how radians work, because 1 radian is not a nice number of degrees. In general, I need you to know that the circumference of a circle is 2 pi times the radius. That's not new. You've been using that formula for years. That means all the way around the circle, how many radii do you use? Well, we use that many. Therefore, going all around the circle means you've gone 2 pi radian. The conversion that we're going to use is the easiest one. It's the one you use in all your pre-calculus classes and whatnot. We're going to imagine going halfway around the circle. If the full circle is 2 pi radian, then half the circle is going to be half of that, which is just 1 pi radian. So pi in radian is the same thing as halfway around the circle, which would be 180 degrees. We're going to use that relationship to help us convert between our angles. So here's what we got. I've got some angles in degrees. We're going to switch them over to radian. I've got some angles in radian. We're going to switch them over to degrees. Let's start with the top row. So take 135 degrees. Basically, what we're going to do is multiply by 1 in the form of a fraction. Now, multiplying by 1 doesn't change the size of the number, but we're going to change how the number looks. The conversion we're going to use, if I've got degrees on the top, I want my degrees to cancel. So I'm going to put degrees on the bottom. So this many degrees is equivalent to pi radian. 180 degrees, halfway around the circle, is the same thing as pi radian, halfway around the circle. Now, to simplify this, here's what I recommend. We're generally going to write our answers with a pi in them. Radian angle measure very often has the number pi showing up in it. Now, as far as what the rest of it looks like, here's what I recommend. Take your Desmos or your handheld calculator, do 135 divided by 180, because the 135 is on the top, the 180 is on the bottom. And then turn that into a fraction. Actually, let me pull the calculator up here. So 135 divided by 180, and then turn that into a fraction. In your math menu, number 1, there it is. So 3/4. Okay. So what I really have is 3/4 pi, or as you're going to hear it referred to, 3 pi over 4. There that is. Let's go again. Start with negative 330 degrees. Going to multiply by, because I want my degrees to cancel, I'm going to put the 180 degrees on the bottom and the pi on the top. Do the same thing. There will be a pi that shows up in the answer. Let's turn this into a fraction. I'm going to use Desmos this time just to make sure we know where things are. So negative 330 divided by 180. And then hit that button in front to make it a fraction. So negative 11/6. So this angle in degrees is the same as the angle negative 11 pi over 6 in radian. Okay, next up, 90 degrees. So I'm starting with degrees. That means I want to cancel my degrees, so I want degrees on the bottom. So notice it's always been the same fraction. Every time you're going from degrees to radian, you multiply by pi over 180. Every time, all the time. Now this one, maybe we can do in our head. 90 over 180, that's just a half. So a half pi, or as you're going to hear it referred to, pi over 2. So radian and degrees are describing the same angle. It's just using different units to get it done. Let's take a look now at this. So these are in radian, and I know that because there's no degree symbol, and because the pi symbol shows up. Now radian, you actually don't write RAD on the end or anything. Radians are technically unitless. But we start with radian. We're going to switch to degrees. And the conversion just gets flipped upside down. So if I want to end with degrees, then I want the 180 degrees to be on the top of the fraction. What will happen is the pi's are going to reduce, and that will happen every time. And then just take your calculator. Do 2 times 180 divided by 9. Okay, so 2 pi over 9 is the same angle as 40 degrees. Let's do the next. Negative pi over 3. The conversion, when you're going from radian to degree, is also always the same. The 180 on the top, and then the pi on the bottom. We do that so that I have degrees left as the unit, and the pi's can reduce. So what I have is 180 divided by negative 3. Okay, so this angle in radian is just the angle negative 60 degrees. Very nice, very cool. Okay, let's do this next one. So 13 pi over 8. So I'm going to take this angle, multiply it by 180 degrees over pi radian. Notice, every time you start with a pi, you multiply by a 180 on the top, a pi on the bottom. We do that so that my pi's can reduce and I end up with degrees as my unit. Okay, I know that that's going to be a 10, so 130 degrees is where we should end up. Being able to convert between radian and degree, the quicker you can do it, the better your life's going to be. For those of you going into pre-calculus, you are going to be expected not only to be able to do this super quickly, but there are some angles where it's frankly just helpful to know what they are. I don't ask you to memorize much, but if you're going into pre-calculus, you're going to want to memorize this list. So 0 degrees is the same as 0 radian. 30 degrees is a pi over 6. And don't just take my word for it. I want you to please do the conversion. Make sure that's where you end up. 45 is a pi over 4. And 60 is a pi over 3. 90, pi over 2. 180 is pi. 270 is 3 pi over 2. And then 360 degrees is 2 pi radian. Again, speaking to those of you that are going into the pre-calculus, it is worth your time to just kind of know these by looking at them and be able to go both ways. So if you're given the radian, know the degree, and if you're given the degree, know the radian.